My name is Jen Scheidler, and I'm the Strategic Planning and Operations Manager at the World Trade Center Institute. On behalf of WTCI, I'd like to welcome you to our second session of the AGILE 2021 Innovation Series, Innovations in Protecting the World's Water Supply. Before we begin our program, I would like to take this moment to recognize several companies who make the AGILE series possible. Our visionary sponsor, Todd Rupert International, our platinum sponsors, RSM and JP Morgan Chase, as well as our gold sponsors, Japaigo, Ports America Chesapeake, Stanley Black & Decker, and Tesco Technologies. Thank you so much for your continued support. And so we have a great session for you today with top experts who will discuss new innovations surrounding water conservation and management. Today, you'll hear from Sabine Stoiber, who's the founder and CMO of Hydroloop, McCall Van Belstoop, who's the partner at Urban Rainshell, and Dr. Jonathan Zohar, who's the professor and chair at UMBC IMET. The session will be moderated by Bruce McIndoe, founder of McIndoe Risk Advisory and WTCI board member. Bruce is a recognized leader, author, and speaker in the areas of global risk management, technology, and intelligence. Formerly, he was a founder of WorldAware, which was recently acquired by Garda World, a leading provider of global intelligence. He has been the industry driver of creating and putting into practice the concept of integrated risk management to protect people, sites, supply chain, and information assets for global organizations. And prior to WorldAware, Bruce worked at the NSA, the CIA, the Department of Defense, and NASA. And throughout Bruce's career, water security and associated risks have continued to increase. He is passionate and knowledgeable about water, the risks of water scarcity, and the urgency required to solve this global issue. So at the end of the presentations today, he will lead the panel discussion and take live questions from the audience. So please welcome Bruce McIndoe, who will provide an overview of the session and topic.
Thanks, Jen. Looking forward to another in this series of focusing on water, and see if we can get everything up and running. So, you know, water is so vital for us, and it's always amazing as we get into the water topic that, you know, most people just think there's a lot of water, and you know, 2/3 of the world surface is covered with water. The challenge is that the water that's there is mostly salt water and not potable to humans. You know, they can't drink it. And so when you start breaking down the fact that only about 2.5% of the water on the planet is water that we can drink, and most of that is actually locked up in ice. And even when that ice is melting, it's going into aquifers, but then ultimately, you know, running to the sea. So we're really left with just a very small amount of water on this planet for us and human consumption and all the uses that we have for water. And so that is the challenge as we continue to consume. And that consumption has led to a lot of challenges. Many of you probably remember, you know, Cape Town going to, you know, days within day zero, which means they would have no water running to, you know, municipally to build houses and buildings. You know, that's a serious situation. Right now in the Western United States, we are in a severe drought throughout Southern California and through the lower Southwest. And you can see across the world where there is substantial water stress that we're dealing with. So this is not something that's hypothetical or we're thinking about the future, such as climate change. These are realities today. And so where is the water going that we're you know, dealing with? And when we talk about shortages, and we're pulling a lot of water out of aquifers that have stored up over hundreds of years or even millennia. And so these ancient reserves are not easily replaced. And so that's what a lot, for example, the drought in the US is driven by, is that we're just, you know, we're basically pulling money out of our savings account, but we're not putting money back in. 70% of that water is consumed in agriculture, and we're going to talk more about that today. But that's the number one consumer. 11% represents what we use for our living and in our cities and those kinds of things. So as we think about this, and we want to make gains on water conservation and water management, agriculture is and continues to be the prime target for managing water. The other obvious thing that we think about is people. And the first session that we had on water and people is that if we don't have water within 2 or 3 days, we die. And when you would talk about an existential threat for a person or human or a community, water is it. And that's why for countries that don't have their own indigenous water sources, it's a national security issue. If somebody turns off the tap, that's it. Obviously, geopolitical issue as countries compete for water. We see that around the world as resources are lessened and people are trying to, need water to live, but also for their crops. And obviously, if there's no water available, then people move, and nation state boundaries, political boundaries mean nothing. They're going to go find where they can get water and live. And so all of these challenges that are generated by scarcity of water are incredibly important. So like I mentioned, this is a 4-part series. The first part last month was on looking at water at the human level. We had 3 great speakers that talked about the actual on the ground impact, how the private sector is stepping in, trying to solve problems at the community level, and a very interesting conversation about the economics, the fact that a lot of times water, when it's pulled out of the ground, there's no cost for it. So starting to set some pricing and have good decisions made based on cost of water. But today we're going to focus on management and conservation. As we said, we have 3 speakers. I'll introduce them as I prepare for each section. And but we're going to kind of work at your home or building or kind of very local scale for Hydraloop. Then we're going to look at cities and neighborhoods with urban rain shell. And then Dr. Joachim is going to talk about aquaculture and how we change the nature of how we produce protein and move from livestock to other protein production, namely fish. So that's our goal today. We have another third in the series coming up in April that I hope you'll keep an eye on. And with that, I'm going to introduce my first speaker, which is Sabine Stuvier. She's the Chief Marketing Officer for and co-founder of Hydraloop Systems. She's an entrepreneur and has been featured in a Netflix documentary called Brave Blue World. And this was awarded and she was also awarded the European Union's Top 50 Award last year for Female Entrepreneur for a Sustainable Innovation. So she's not only brilliant, but innovative. And welcome, Sabine, and let's hear about Hydraloop and what you're doing.
Okay, then. Can you see my full screen?
Perfect.
Perfect. Well, Bruce, wow, what an introduction. Thank you very much. And thank you for having me here today. So my name is Sabine Stuiver. I'm the CMO and co-founder of Hydraloop. Now, Hydraloop is actually a global leader in designing and producing game-changing and very innovative decentralized water recycling products. And last Monday was World Water Day, so I think it's an excellent moment to talk more about water, which we actually call our blue gold. And now the only thing is I'm getting to the next page. And here, so I'm going to be talking about the decentralized water recycling and creating a sustainable future. Now, Bruce has already told quite a bit about it. We have a massive challenge. We have too many people and more people coming on the planet. So we have a massive, serious water problem. And here also, he was talking already about America. This is the drought monitor you see on the right from February. And you can see actually on the colorings, the severe drought that America is facing. And not only America, the world is facing. So not only we have a vision, but this vision is also substantiated by a lot of trends and papers that are coming out. And I'm showing you some of them here. On the left, high up, you see the 50-liter home coalition led by Procter & Gamble, which is aiming us to go and use only 50 liters per day in the home. But also on the left at the bottom, this is a double peer-reviewed paper from the University of Ghent, which is actually saying that we should use extreme decentralized water recycling to create a resilient urban water systems. And also on the right, you see the UNESCO report, and I can go on with this. So more and more research is pointing to the same direction, to our vision of the future, and that is to use water twice. And we think basically that it is very easy because we can be so much more efficient in the use of water by using decentralized recycling, water recycling as an alternative source. And we look at it like this. Every building has its own water source. And this is lightly contaminated water. So you have to think about hand basin water or shower, air conditioning, cooling water, etc. And if at the building, at the spot, decentral, we can collect this water, treat it and disinfect it, and so it can be reused again on the spot, you can actually save up to 45% on tap water supply, and you also have a lot less wastewater. It's also 45% less. Now, what kind of water can a system like this actually treat? I was already saying some. So air conditioning condensation water, heat pump condensation water, bar shower water, washing machine, hand basins. And then the output is safe, clean, disinfected, recycled water. And this can be used for several purposes like flushing toilets, the washing machine, garden irrigation, or topping up the pool. And obviously the I think I lost one page. No, I'm sorry about that. So we have created a very new treatment process. That is also, we've patented it, and that's also why we're winning so many awards, because we do not use filters or membranes or chemicals. Now, chemicals are not sustainable, so we're not going to use them. And filters and membranes work perfect in water treatment, but they clog and they need a lot of maintenance. And we wanted to create a consumer product that needs very, very little maintenance. So what we've done is we've combined 6 existing techniques, which you can all see here. And that is very unique. And with that, we have created a completely new water treatment technology. And obviously, the water that then comes out has to comply with the highest international standards, and it does. To visualize it, on the left, you see the water going into the system, and on the right, you see how it comes out. And I'm very happy to say that we are meeting the NSF 350, well, don't only meet them, we are actually certified for NSF 350. So the water quality is perfect for all the usage that I just mentioned. Now, all the systems are remotely controlled and monitored 24/7 in our server. That means we offer remote support, proactive maintenance advice, and over-the-air software updates. And all this information is returned back to the customer, and that gives them the information. It enhances their awareness of how much water they have used or saved. They can find an optimum in their water efficiency, but they can also change their priority settings, and it empowers customers to use their water in the way they want to use it. Return on investments. This is asked a lot. What is the return on investment on a system like this? Well, sometimes I think, why do we talk about return on investment when we're getting close to day zero? But it depends on country, region, and municipality. It can be between 2 and 12 years, depending on where you live and the price of water and wastewater. But some of the benefits are anyway, 45% savings on tap water consumption. You reduce your wastewater also with 45%. You have savings on your waste and water bills, but there's also an energy reduction component and a carbon footprint reduction. It increases the property value because it complies with increasing regulation and sustainability requirements, and you become more resilient and off-grid. Now, since 2018, we have come to market with the H300, the Hydroloop H300. This we created for the home for a family of 4 or 5 persons, and we sold already in many countries in Europe, Middle East, and Southern Africa. This year, in January, last January in Vegas at the CES, we launched the Hydroloop H600. Now, this is the bigger brother, so to speak. It is for larger families, for small boutique hotels, etc. And this is the Hydroloop Cascade. And this is a modular and scalable made-to-measure system. So now we can do student housing, sports clubs, swimming pools, offices, etc. So any kind of size of or volume of water we can treat. And this also complies and contributes to BREEAM and LEED certification points. Now, to give the face, the company, this is part of the team, because actually this picture was taken in September and we've already grown to 23 staff right now. Some of them are in the US at Hydroloop Inc. And we're actually just opening a joint venture in the Middle East as well. Our systems are Dutch designed, made in the Netherlands. So here you can see some of the pictures of the factory. And this is actually the vision that we are propagating everywhere. All construction should be built recycle ready, because you're building for the future, you're constructing for the future, and it can so easily be prepared for the installation of a water recycling system, because the plumbing is at hardly any extra cost, and it's very to do when it's a new construction. And now in the coming 20 to 30 years, all other buildings will be made more sustainable or will be changed. So then it's a perfect timing to also install a decentral water recycler then. To give you a beautiful example of one of the many projects we're doing right now, this is a new smart city blueprint project in the Netherlands. These are 41 homes, they're gas-free, there were solar panels, all building materials are recycled, and they're all built recycle ready, and they all have a Hydroloop water recycling system inside them. We have many happy customers. Go to our website and read all their stories, but this is just to give them a face. This is also a very happy customer, one of the many that we have. This is in the leisure, so this is in the hotel branch. This is in Namibia. All lodges have their own Hydroloop system. And this is a student flat that we just finished. 350 students living in here, and the Hydroloop Cascade, recycling millions and millions of liters for their toilets. Bruce mentioned it. If you haven't seen it yet, go and see it. It's a very uplifting and informative documentary showcasing all these solutions to save our planet. And we're very, very proud to be part of it, of course. And we do not only comply with 4 and contribute towards 4 of the UN Global United Sustainability Development Goals, but as you can see, we've also been winning quite some awards, of which the biggest and the best was last year in Vegas, winning best of the best and beating 20,000 other products, of which we're of course extremely proud. Now, why am I here? To tell you about decentral water recycling, the power of it. And but also we have so much demand from all over the world, and you see on the map already that we have 65 partners in 4 continents, but we need more. And so we're looking for collaboration and connecting with architects, real estate developers, installation partners, local and city governments, water utilities, wastewater treatment companies, so we can complete our mission. That is that within 10 years' time, no building will be built without its own decentral water recycling system. It will not only be a Hydroloop system, we will not be able to do that, but we would like to be the Tesla of the water recyclers in the world. Okay, so this is our motto: be wise, use water twice. And if you need any more information, you can find my details here, and otherwise contact Fernando Ramirez, our MD at Hydroloop Inc. Thank you so much for your time.
Thanks, Sabine. Awesome presentation, and obviously an awesome product. So we're going to talk more about that in a minute, but I'm going to introduce Michael Stoop, who's the partner and international business developer for Urban Rain Shell. And she's going to take this from kind of the living home buildings to your neighborhood and even city. And so she is, her background, she's an architect, and she has a master's in restoration of old cities and buildings. So with her love of cities and love of water conservation, Michael, I'll turn it over to you.
Thank you very much, Bruce. And I will share the screen with you and start my presentation. Hello, my name is Michal van Bellestoep and I'm representing Urban Rainshell. We are a Dutch innovation company that has designed a nature-based, integrated underground stormwater harvesting and treatment solution. Climate change not only causes heavy rainfall damaging public and private infrastructure, as we unfortunately can witness at the moment in Australia, and it also causes a longer period of drought that put pressure on our sweet water resources, agricultural production, and nature. Next to the stress that human and nature suffer, climate change brings an enormous impact on our economy. Urban Rainshell offer a natural-based solution to become more resilient for heavy rainfall and drought. We buffer, purify, infiltrate, and reuse rainwater with a patented system that uses natural and circular materials as much as possible. Our Urban Rainshell stores stormwater in underground beds of seashells. Instead of temporary buffering and discharging stormwater as fast as possible to our rivers and sea, with the Urban Rainshell, we store and use this precious rainwater. Our system is natural-based, super environment-friendly, uses no energy, absorbs CO2, and depends very low in maintenance. It can be applied in every location regardless of the existing infrastructure. It supplies a long-term solution from which multiple future generations can benefit due to its circular design. We created the following animation to show you how Urban Rainshell works.
This is Urban Rainshell, and here's how it works. Rain arrives via the roofs, streets, sidewalk, and gullies into the supply drain of the Urban Rainshell system. There, under a foundation of at least 30 centimeters, millions of washed seashells collectively form a buffer in which heavy showers can be stored very quickly. The shells have a 70% hollow space and function not only as a buffer, but also as a natural purification station for the rainwater. As a result, the system breaks down organic pollution, preventing the system from clogging up. Moreover, the shells are lightweight and CO2 binding. After going through the shells, the rain is led to a drain via the innovative mineral mix AA Minerals. AA Minerals is specially designed to remove heavy metals, mineral oils, and PAHs from the water. The rainwater is now completely clean, so it can be safely infiltrated into nature reserves, groundwater protection areas, or into aquifers in the deep subsoil, where it can form a freshwater bubble. Also, the rainwater can be meaningfully used for all kinds of applications, such as sprinkling sports fields, as firefighting water, or as play water. The system can be applied under green areas, parks, or in combination with wadis, but also under town squares, parking lots, or roads. Depending on the application, a different foundation structure must be chosen.
In the next slides, I will present to you some of the features of the Urban Rainshell. Our natural material to buffer stormwater have an extremely high buffering capacity of 70% and an enormous infiltration speed of 1,300 meters per day, allowing the rainwater to be stored very quickly. The shells break down organic contamination, and the innovative mix of recycled minerals removes typical urban contaminations such as heavy metals and mineral oils. Our system is using neutral material and reduces therefore the use of plastic. As our system uses gravitation, there is no external energy source needed for buffering nor for water treatment. After the filter lifetime, it can still be used as building material without damaging the environment. In this way, it will not create waste stream. The system breaks down organic contamination and therefore doesn't clog and is easy and cheap to maintain. It can also be designed to be fully functioning up to 80 years. Due to the nature of the material used, the system is not bounded to any standard dimension and is very flexible in shape and size. In addition, its flexibility allows the Urban Rainshell system to be used with high groundwater levels. Another benefit is that it can be integrated in an existing underground infrastructure with cables and pipes. The Urban Rainshell system has no standard size and can therefore be easily adapted to the requirements of a specific location. The lightweight nature of Urban Rainshell makes application in areas of land subsidence very interesting due to the reduced risk of settlement without the risk of buoyancy. The Urban Rainshell also binds about half of its weight in CO2. With the Urban Rainshell system, rainwater is made suitable for reuse, thus saving drinking water. Rainwater can be made available for various applications, such as for irrigation of sports fields or public greenery, as firefighting water, as play water, process water, etc. For whom is our system interesting? Well, for every party who needs to adapt to climate change and prefer to do so with nature-based, ecological and low-maintenance system. More specifically, municipalities that suffer or risk severe economic damage to the stormwater and drought, municipalities and companies that are not able to buffer and infiltrate stormwater due to environmental legislation, or companies or organizations that buffer stormwater and increase pressure on sweet water resources and drinking water abuse. Urban rainshell is not only ecological friendly, but also economical friendly. To prove that, here's an example. It is a system which was designed for the size of 4 hectares and for the use of 30 years treatment capacity in Houston, Dallas. In this case, there are 28,000 cubical meter treated water made available per year. In Houston, the present price for 1 cubical meter drinking water is 59 cents. The price of 1 cubical meter sweet water filtered by urban rainshell in Houston is 44 cents. That is 25% saving on price of available sweet water and return on investment of 172% over 10 years. Which means that urban rainshell is not only a great way to prepare for the climate change, but also a great investment. In the next part of my presentation, I would like to show you different locations where the urban rainshell is already installed. In the municipality of Goes in the Netherlands, our system was installed under a hockey and rugby field with the purpose of minimized drinking water use. In this location, urban rainshell makes water available to irrigate the fields before each game. Next to the Natura 2000 area, which is European Union Protected Nature Reserve, our system treats contaminated water, thus allowing it to be infiltrated into the protected reserve. In this way, the municipality saves a lot of costs on pumping the previous contaminated runoff water out of the area. In the next location, the water produced by our system is being buffered and used as firefighting water supplies. During dry periods, the firefighting water system can be refilled from the aquifer that is recharged by the urban rainshell system during wet periods. In the city of Amsterdam, our system was installed nearby a parking lot. The water is being used as play water in playground. In this case, the municipality of Amsterdam have chosen to keep part of the system visible. In this way, the AI eco shells also function as elements to play with. In the city of Zoeterwoude, urban rainshell was installed under a road in a residential area in order to prevent damage from flooding. The water is treated and discharged safely into a surface water. In Belgium, we have installed our system next to a shopping mall, protecting it from overflow. The filtered water is used for irrigation of public kitchen gardens and as play water. Our last completed project was built next to Proces in Den Helder. The objective is to sustainably use rainwater as play water and as process water. In this case, a cooperation was made with the next door beer brewery, which is using the processed water in the production of their beer. We believe that many other companies and entities can benefit from the advantages of the urban rainshell, such as hotels. Hotels can prevent water damage to their infrastructure and the inconvenience for the guests. The filtered water can be used to water their greenery, filling their swimming pools, or create playgrounds with water for the guests. In gas stations, for example, the urban rainshell can help the companies to protect their environment from contaminated runoff water, helping to improve their corporate social responsibility and meet local environment legislation. Insurance companies may be interested to present our system as a measure required in order to prevent the great damage created by heavy rainfall floodings and or droughts. If you are interested in benefiting from the advantages of installing our system in your organization, please feel free to contact us for more information.
Michael, it's wonderful, and I can only hope when you have a whole series of projects in the United States to show off. How's that?
That's definitely inspiring. We would like to spread the news wherever it's possible. Really, everyone can so much benefit from it, and there is so much advantages in the tweets to the climate change. I really hope to be much more active in the States indeed.
Good. Well, we'll talk more in a minute. But next, I'm going to bring up our last panelist, which is Professor Zohar. He's the chair of the Department of Marine Biology and director of the Aquaculture Research Center. He was also formerly the director of IMET here, the Institute of Marine and Environmental Technology with the University of Maryland. He has over 40 years of a significant record in the field of marine biotechnology and a focus on sustainable aquaculture. He's published over 240 peer-reviewed papers and book chapters. He's an inventor of about 10 international patents in aquaculture and biotechnology. And Dr. Zohar, you're going to talk to us about manufacturing protein, right?
In a way, yeah, but
Go for it.
We are certainly going to switch gears here, and I'm going to talk to you about water and environmentally responsible fish farming, which is also referred to aquaculture on land. Here you can see the building of IMET, where I'm sitting right now, which is in the middle of the beautiful inner harbor of the city of Baltimore, Maryland. And I'm going to start with a quick quiz here, although I cannot hear your answers, but these light blue shapes represent the water footprint of animal and plant crops. How many liters per kilogram meat or food you use in different animal and plant crops? And I will ask you, so which animal or which crop, sorry, is using most water? And I don't hear your answers, but when I do ask that question, most people will say, well, yeah, fish, they swim in water, they use most water. Well, surprise, surprise, here is the answer. Beef uses most water per kilogram meat. Then you go to pork, then you go to chicken, rice, wheat, corn, potato, and here you are with fish. So fish are the winner. Fish by far are the most efficient users of water per kilogram meat produced, per protein. But those are fish grown in RAS, recirculating aquaculture systems. We'll get back to it in a second. Not only that, but fish are also the most efficient feed converters into proteins. And you can see here, this is from National Geographic. A few years ago, cattle is using 6.8 pounds per pound of meat, pigs 2.9, chicken 1.7, and fish only 1.1. And feed takes water to produce. So again, fish are the most efficient water and feed producers. Users. So how do we do that? You know, especially for the water, so little water used. Well, we have to back up and say that it all starts with the fact that fish are the last hunt and gather animal crop. We really are emptying our oceans using factory ships, like you can see here, small fleets, huge industrial seine nets or other type of nets, and we're going out there roaming and emptying the oceans. And if you think about it, you don't go to the wild to catch your chicken, right? Or you grow them in agriculture. You grow them like that, and you don't go to the wild to catch your cattle or pork and so on. But you do it for fish, which is quite sad, because it leads to what the Economist has actually referred to as the tragedy of the ocean, emptying the ocean. But the Economist also a few years later talked about the blue revolution, the promise of fish farming. And indeed, we are witnessing an increasing what we call the global seafood gap. In yellow, you can see the rapid increase in the demand of fisheries products in seafood because of more people on the planet, and more people eat more fish, and because of the health benefits and so on. While the demand, the supply fisheries at best is stayed at level. Actually, it's on a decline. So this increasing gap is something that we are all witnessing right now, and the expectation is for aquaculture to fill this gap, growing fish, seafood in controlled condition to fill this increasing gap, and it's a big challenge for the industry. But aquaculture has responded to this challenge, and indeed we see that aquaculture has been the US and the world fastest growing sector of agriculture. Here you can see in orange, the orange bars show the relative contribution to to seafood consumption that comes from aquaculture in orange and from fisheries in blue. So you can see the huge increase, and actually a couple of years ago was the first time that we consumed more fish coming from aquaculture compared to fisheries. And actually the value of the aquaculture industry right now is about globally $260 billion. And I don't know how many of you know, but currently we consume more farmed fish than beef. And you see, this is just the beginning. It's going, really up. The problem is that most of the current practices, these fast-growing practices of aquaculture, have not been environmentally sustainable at all. They are mainly fish are grown around the world. 98% of fish farming is in those kind of what we refer to as floating net pens in many coastal areas, beautiful fjords like here in Norway, and so on. And the issues are environmental or chemical pollution. So there is a lot of runoffs from the fish net pens into the marine coastal environment. There is biological pollution, some fish that are selectively bred and some fish that are non-native, Atlantic salmon in the Pacific Northwest, they escape, and there is biological pollution and disease transmission that goes actually both ways. Farmed fish have been blamed for transmitting disease to the environment, but it is the other way around. So this is not environmentally sustainable. So we here at IMET and many others have been working on developing your next generation of aquaculture technologies that are land-based, fully contained, and recirculating. So the recirculating aquaculture system, you can see these pictures at the bottom here to our tanks. These are tanks in our fish tanks in our basement, right underneath of where I'm sitting right now. And what we do, we start with city water. Sounds weird, but you'll understand in a minute. And we make artificial seawater, simulating the exact condition that we can simulate the Atlantic, the Pacific, the Gulf of Mexico, the Mediterranean, and so on. And then we recycle the water again and again and again. They recycle in the system. We reuse the water. And the secret to the success is in those drums, cylinders, we call them biofilters. So there are friendly microorganisms, bacteria from the marine environment that live in symbiosis with the fish, and they remove the chemical waste produced by the fish and the water recycled. And as such, we develop systems now that are zero waste to the environment. They are disease-free. They are flexible. We can do high temperature, low temperature, salt water, fresh water. And as such, they are generic. We can diversify. And you'll see how we diversify in a minute. And they're applicable for rural and urban location. They can go anywhere. We don't need to be by the sea or by a lake. And therefore, they can go to be next to your markets, next to your airports, and you reduce the carbon footprint of your operation. And here's one example, how we use marine methanogens, microorganisms from the marine environment, that converts the organic solid waste that produced by the fish into fuel-grade methane. So right off the fish tank, you can start a Bunsen. Here you can see to the left, or you run a methane-driven generator, biogas-driven generator, and produce electricity. And so we are converting the waste into fuel-grade biogas that is used to offset the energy cost of the operation. Now, here is a quick, sorry, I'm trying to run, yeah. So you can see this is downstairs. I mean, these are bronzini, so the European sea bass. You see how they swim in our tanks, very clean, pristine water. And it's totally recycled and produce this bioenergy. We also do it for the Maryland's Holy Grail, which is a blue crab. We close the life cycle, develop hatchery technologies for the blue crab, and Steve Phillips, who is, I think, a board member of the World Trade Center Institute, has been very helpful in and supported this project, the blue crab. But salmon is king. Atlantic salmon is king, the most important fish right now. You know it, you go to the supermarket, you see it and so on. And those are at harvest size, like 8-pound Atlantic salmon in our tanks downstairs here. And indeed, land-based recirculating aquaculture system salmon production has been a booming industry as we speak during the last 5 years or so in the United States, with about $5 billion of investment. And it's really around the country. You can see here from Maine, a few operations in Maine, and in New York, upstate New York, and in Maryland, major investment in Maryland and in Virginia. And you grow Atlantic salmon in Miami, Dade County in Florida, as well as in the West Coast, California and Nevada. So, and this is really like growing immensely right now. And I'll just give you very quickly a few examples. Aqua Bounty, a company that grows Atlantic salmon on land in Indiana. They produce about 4 million pounds annually. And those are like large tanks in a warehouse, much larger than what we have right now in our system. Those are like 70,000 gallons. They are about 36 feet by 10 in diameter, 10 feet deep. And you can see high densities of fish in pristine water. This is for Atlantic salmon. This is in the middle of kind of nowhere in the boonies, you know, Superior Fresh in Wisconsin. 2 big buildings, like 6 acres, they're going to 1.5 million pound annual production. And you see to the left, you see the building with this a little bit lights. Those are LED lights. So the nice thing about Superior Fresh, to the right, the warehouse to the right, they grow Atlantic salmon, beautiful quality salmon in recirculating system, land-based. And here they use the waste from the fish to grow leafy greens. So it's a beautiful integrated operation. Moving to Atlantic Sapphire in Miami, they produce about 20 million. They already sell fish, 20 million pounds, and everything is new. Nothing of this existed 5 years ago. Those are big tanks. This is when they were like building the operation, 450,000 gallon tanks. It's a $270 million investment. You can see when they put the fish into the warehouses here as they build them. Now they already sell the fish. You can buy them at Wegmans. Veolia, you all know Veolia. Veolia went big times into the field of recirculating aquaculture system. Aquaculture, RAS 2020 is the one tank that is 150 feet in diameter, producing, have 1.8 million gallons of water, just one tank, and producing 2.4 million pounds fish. So this is huge. This is like, and this is all in one warehouse. And so by 2-3 tanks like that, and you are a large scale operation. And finally, in Maryland, a company by the name of Aquacon is in the process of getting permits and engineering and design of very large operation, investing up to, in a first operation, $330 million, but they're going to invest up to $1 billion when they're going to go from the 15 to 45,000 tons, 30 to 90 million pounds. They're going to, and the building, just the building is 30 acres building. And you see that all the roofs are covered with solar panels. So those are very green, very environmentally responsible and compatible type of operation, zero interaction with the environment. So I think that I was able to convince you, and this is another tank of another fish here. This is the Orata, the Mediterranean sea bream, that the blue revolution is here to stay. I'm happy to provide more information for anybody interested, and I wanted to thank you very much for your attention.
Thank you, Dr. Zohar, and already questions about how do I get one for my home?
Just a second, I need to stop.
So I assume that these are efficient at scale, not at home scale for growing your own salmon. Huh?
It's all about economy of scale in this operation, like many other things.
One thing that I'm curious about on the biogas, the methane, like how much production, is that really just an exercise in the lab, or is this commercial viability?
So we already, it's a very good question. We already started to implement it commercially. IMET and in Norway, you know, Norway is the largest salmon producer in the world. And there is one commercial operation in one salmon farm that is large scale. And actually the experience is that the biogas that is like a bonus, right? It's an added value because you wanted really to treat the waste, that it will not go to the environment. There is enough biogas to offset about 10% of their energy costs in the operation. So it's quite significant.
Okay. And really tongue in cheek about residential, I guess if somebody's interested in actually looking at investing in this, they could get information from you, or is there another source for, you know?
So yeah, there you go to the internet, you find many, but we are working at IMET, we're working with most of the industrial producers, the commercial companies that are now investing this $5 billion in the United States. So I'm happy to make connections and to connect people and provide more information.
Okay, then you left your email, and I'm sure they'll reach out to you. Sabine, one of the things that when I was watching, and it also came up in the Q&A, was once the water is buffered and you have it, and I also noticed you're using it for playgrounds. Can you drink the water? Is it to that level of, or does it need to be further filtered and purified?
Yeah, well, we don't use it for playgrounds. I think that was actually, sorry, my phone is just ringing. That was actually Michal's. But no, but to answer your question, we do not create drinking water because we don't need it. Because if you look at the balance in the building, or let's take a home. If you look at how much water is being used, tap water for showering and for a washing machine, and that is the water that we then collect in the hydro loop. And if you then look at how much water is also used for toilet flushing in the washing machine, they balance each other out. That is the 45%, less tap water and less wastewater. So basically, we decided to do it that way. Therefore, we do not need filters and membranes, because if you want to go to that next step of making drinking water, you know, you will need filters and membranes. And, you know, we only drink a few liters. So it's not,
so yeah,
this is much better.
I wanted to talk to Mikhail about hers, but let me finish with yours then. So you are creating this gray water, right? So what impact does that have, if any, on the municipal water systems and sewage and those kinds of things?
Well, if anything, I mean, if we're talking really large scale, which we are, you know, we are growing now. So if we're looking at new construction, new build, I'm going to give you an example in Lausanne, here in Switzerland, in Europe. A project developer wanted to have 16 flats, 16 apartment blocks with 50 apartments in them. So we're talking 900 apartments. And basically the whole project was not granted by the local government because they couldn't, the infrastructure wouldn't be able to handle it. Basically, there was not enough pressure to get the water there and to handle the wastewater. Then we came in with so it's all hydro cascades in every single block. And now it has the green light. So it can be very, very beneficial. Some people think that, you know, basically that there will be not enough water being uptaken, but because we are getting so many more people and so much more construction, and the infrastructure is already so much under pressure, it's actually very good that we will use less water because we're going to be more people.
Sure. Okay. All right. So you're generating gray water that can be used for lots of things or purified for drinking, but mostly for reuse for other activities. So
that do not need drinking water quality.
Yeah, exactly. Right. So on your program, that's when I was also, you know, you're basically filtering this water naturally. And I saw the beautiful clean glass of water. So tell us about your water and whether that's actually usable as, you know, potable water.
Is this a question for Michal?
Ask me?
Yeah.
Okay.
Sorry.
All right. So now, yeah, the water we purify or the filtered is sweet water that we can use different, it's not a gray water, we can use it in different applications. When you asked before, our water at the moment, we did not approve it to be drinking water. Can technically, however, can be done, but then for that we will need a bit another step of purification, and we are not really interested to work with that because the complex of the legislation involved with that. And the main thing that is very important with drinking water is the monitoring of the water, actually in our case also coming into the system and going out of the system. So we believe that the water we produce can be replacing the use of drinking water in so many applications, and we focus on that as a step.
Yeah, that is kind of the, especially in the United States, where we spend all of this money purifying and stabilizing and putting, you know, chemicals into the water to drink it, and we pump it out everywhere in the city and use it for everything. And I think, like Sabine said, a very small amount actually is consumed by us, either drinking or in food preparation, and it's really discouraging to see. Yeah,
exactly. The rainwater, otherwise, if it's not going to our system, it's just going back to the sea or to the rivers, and we able to make it a quality water that can just replace the drinking water that we need so much.
Can I just say, yeah, this is exactly what Michal is saying, is exactly the same with us. You know, so there is no need to bring it up to the drinking water standard. And may I just say that the water that we are creating, what goes in is gray, and what comes out is recycled water. It's not gray. And as you've seen, it looks good. Just wanted to put the record straight.
Sorry, yes.
Good. So, Dr. Zohar, you have to put your microphone on, but you mentioned that you start your whole production with city water. So tell us a little bit about why that is. Why can't you just use rainwater, for example, to fill those huge tanks?
No, we could use rainwater. I mean, absolutely. The whole point is that you don't want to take any water from the environment because, I mean, issues with viruses and bacteria and pathogens and pollutants and so on and so forth. So we start with city water that actually we run, even the fish start to swim in water that is cleaner than the water that we drink because we run them through activated charcoal filter. And then we simulate then the marine environment that we are interested in. So if you're a Mediterranean fish, you're going to experience Mediterranean water, or you are in a freshwater fish, just a freshwater. But the point is that once you fill up your tanks, it goes for years. I mean, you reuse that. The only water that you replace is for evaporation. So if there is evaporation, this is the only water that you have to add up to your system. But otherwise, you recycle the water. This is why the water footprint is so low.
Okay, yeah. So one of the questions that came up, because you mentioned AquaCon in Maryland, and they were asking, are there other projects, or is this really the first one?
Well, Maryland has a history. You know, I've been in Maryland for 30 years. And, you know, when I started here years ago, you know, there was a lot of rockfish and, you know, striped rockfish aquaculture, but it didn't, I mean, survive. And so Maryland is all about oyster, really oyster aquaculture. But Maryland is like a state, a seafood, you know, kind of a state. And AquaCon chose to come to Maryland, to the eastern shore of Maryland, and for the first large scale and one of the largest in the United States salmon operation. There are a couple of other efforts. Yeah, there is another group that is also trying to do the same, more like on the western shore of Maryland and so on. But AquaCon is the one that is moving forward the fastest, and they're going to, actually, they have already a shovel in the ground. They started to dig for the wells and things like that. So they are going, referring to your question, they are starting with well water, okay? And they're going to make their artificial seawater, and then they're going to recycle it.
Okay. A couple of just other quick questions while you're talking is that one is, and this always comes up with any kind of, you know, closed loop farming like this, is the humane nature of it. And also, is there a chance that infections could be, you know, where, you know, transmitted and a whole tank of fish would be infected and have to be destroyed. So talk a little bit about those challenges.
So the animal welfare, actually, you know, I think this animal welfare in those systems is much way better than what is in the floating net pens. Actually, because we can optimize it's all about the ability to optimize the condition to allow the fish to feel, best and for optimal performances. And you saw the water quality, which is pristine. And those systems, and it connects to your other question, are disease-free by definition. So again, this is why we start with well water or city water, and then we recycle it. And those unless you do a mistake and you introduce a disease, there is no infection. Those systems are diseased. The fish are even not vaccinated. You take fish to any other operation in the floating net pens, you vaccinate the fish. Here you are not, because those systems are disease-free, infection-free, viral-free, bacterial-free.
Okay. Mikhail, there's an interesting question. With all the shells in your system and you're filling it up, do those crack and compress and end up with any problems with installation over time?
No, it doesn't. So of course we're running through all kind of tests, and it was tested in different municipalities, and it was tested in the organization of the Dutch Asphalt Knowledge Center. And we treated the shells we were using, and also learned what kind of structure or infrastructure needs to come above it in order to protect the shells. So no, the shells staying straight, they're not breaking down, and that's why they're also, to continue have the capacity to store water and infiltrate the water into the ground.
Okay, awesome. And then Sabine, will give you the last question here. And that is, obviously that your system is easier to install in new construction. But they're just wondering, kind of what do you see as the growth of this and people embracing this? Would it mostly be builders and architects for new buildings and new construction? Or do you see people being able to retrofit homes to use your product?
Yeah, we see both, and we see a lot changing. And actually, we are changing our business plan according to everything that is happening at the moment, because everything starts to be pointing to the same direction, that, the whole water scarcity problem, and also due to the whole COVID situation, I think it has really made people far more aware of hygiene and the value of water. And of course, you have a new administration in America that is also gearing far more towards sustainability, etc. So we are now, working together with water utilities, actually, together with them, installing them in homes. So new construction is always easiest at the moment, because, you do it on the drawing table. But we're doing a lot of, as I said, all buildings within the next 20, 30 years, every building will go through some kind of refurbishment. If you buy a house and it's all old and you want to go and change that, and you change the whole thing, then you're doing the plumbing as well anyway. So, but if your house is brand new and you've just bought it and, it's all fixed and everything, then it's a bit of a shame to do it then. But we look at it a little bit, if I may say, as that this will become a staple item in every single home, like a washing machine or air conditioning, in the coming 10 to 15 years.
Especially in those cities that are facing day zero with water. So thanks everyone. This has been really awesome. It's so exciting to see what people are really doing to change the whole trajectory. And thank you, and keep up the good work. And Jen, we'll turn it over to you.
That's great. Thank you so much for your presentations. They were so interesting. And thank you so much to Bruce for moderating, doing a great job per usual. So next up in our Agile series on Wednesday, April 14th at 11 a.m., WTCI is hosting part 3 of Innovations in Protecting the World's Water Supply, focusing on water and the environment. And at this session, we will shift our focus from global to more local. Joining us will be Mark Breyer, who's the Chesapeake Bay Program Director at the Nature Conservancy, Tony McRory, who's the Senior Director of Environmental Health and Safety Compliance at Walmart, and Jaleesa Tate, who's the State Hazard Mitigation Officer at the Maryland Emergency Management Agency. The speakers will discuss the role of climate change on water scarcity and share innovations in flood resiliency and water quality improvement in Maryland and beyond. So please visit our website at wtci.org/agile to register. Now, I'd like to make an important announcement for the Maryland Department of Commerce, the Netherlands Water Partnership, and Baltimore Rotterdam sister cities who've played an integral role in this program. So the state of Maryland has a memorandum of understanding with the province of South Holland in the Netherlands, the province where the cities of the Rotterdam and The Hague are located. This collaboration is focused on cybersecurity and life sciences and health, and it is expanded to include water management, green tech, and agri-tech. South Holland serves as a gateway for Maryland companies to Europe, and Maryland serves as a gateway for Dutch companies to the US. Companies can partner to cooperatively address many issues that are of concern to both regions. Companies can benefit from soft landing programs to help them expand to each region. The Netherlands Water Partnership is an organization based in The Hague for Dutch water management companies and research institutes. And in January 2021, Maryland and the Netherlands Water Partnership, together with other organizations like Baltimore Rotterdam sister cities, held a joint conference on climate resilience, which addressed issues with rising seas and flooding. Participants included representatives from the public and private sectors. This conference initiated an increased level of activity between the two regions to work together in areas regarding water resources and finding nature-based solutions for flood management. So if you're a Maryland company that would like to expand to Europe via the Netherlands, or if you are a Dutch company interested in expanding to the USA via Maryland, contact Andrew Kreinik at the Maryland Department of Commerce. Maryland and the province of South Holland both offer tailored business soft landing programs that help your company make the move overseas. So that concludes our session. We hope you enjoyed it, and thanks so much for joining us. And we hope to see you again at the next session on April 14th.